Hello all, my name is AC and today I'll be teaching you some math. Today's section is 11.2 Area of Parallelograms and Triangles from the Enjoyment, Geometry for Enjoyment and Challenge textbook. Let's get started. First one, a regular hexagon with a perimeter 60 and we have to find the area. So, first I'm going to construct the freaking... Alright, so this is the hexagon I drew. Could be better, but whatever, it does this job. So we know it's a regular hexagon, and in a regular hexagon we know that all the side lengths will be the same in a regular hexagon. So because the perimeter is 60, what we can do is if there's 6 sides and the perimeter is 60, divide 60 by 6, so we know each side is 10. So we have our hexagon here. Now, how are we supposed to find the area of this figure? Well, first off, I think the unit gives you a little bit of the hint. We need to make either like a parallelogram or like a triangle. What we can do with this shape is split it into a bunch of other shapes that will make it easier to solve for the area of. So I'll give you a second and try to find out what shapes you can make from this hexagon.
And I geek like a nerd. Head up the guys like bro, it's the word. I'm fly like a bird. And they really want beef, niggas spend 2/3. But you know they ain't spinning, I strip.
The way I would approach this problem is I want to make the shape as easy as possible to solve. So I recognize that both of these two sides are parallel because it's a regular hexagon. So what I'm going to do is I'm going to create two little I guess you could call it altitudes, but I'm going to create two little lines like this, right? This is already a much better shape than the hexagon. Now we have a rectangle and 2 triangles to work with. Now, because we've created a rectangle here, we can assume that because of a rectangle property, each angle is 90 degrees. Now, you might be thinking, how do we solve for this angle here? Well, we can use the formula 180 minus 360 over n, in which n is a number of sides. This is how we find the measure of an interior angle of a hexagon. And we already know what n is, so it's 180 minus 360 over 6. So it's 180 minus it's 180 minus 60. Okay. We know this is the interior angle of this hexagon here. So we know this is 120. We know this is 90 because it's a right angle. So from that we can assume, or we know that this side will have to be 30. We know that this side will have to be 30, and so will this one have to be 30, and this one, and this one. So what I'm going to do is I'm going to split this triangle by its altitude. And because this is an isosceles triangle, I know the altitude will also be the median. So I know that all these sides right here, this one, this one, this one, and this one, they're all congruent. If you know all these are 90, we can just know that every single triangle has 180 degrees, all of its interior angles, to find that 90 plus 30 is 120, 180 minus 120 is 60. So we know each of these angles is 60. This actually makes a 30, 60, 90 triangle here. And just like right here. And with the 30, 60, 90 triangle, we know that the sides are in the ratio of x to x root 3 to 2x. Using this, we know that the side opposite of 30 degrees will always be x. So we do here, the side opposite of 30 degrees will always be x. And because this side is 2x, I know that this side is 5. And these are all congruent, so you can keep it the same. Now, I know that this side will have to be x root 3. And in that case, x root 3 would be 5 root 3 because x is 5. We can officially start to solve the area of this hexagon. Let's start with the easiest shape, the rectangle in the middle. So we know the base of this rectangle is 10. And the height of this rectangle is 5 root 3 plus 5 root 3 or 10 root 3. So the math is simple as 10 times 10 root 3. And you can imagine this as 10 times 10 times root 3, or 100 root 3 units squared. So we know that this rectangle right here is 100 root 3 units squared. Now we just need to find the area of each of these triangles here. A little tip I like to use whenever calculating the area of a triangle is, alright, editor AC here. Basically what I say is that in the formula, base times height over 2, which is the area of a triangle, instead of using base times height over 2, where trying to divide a number like root 3 here, for example, could be too complicated, or like 1, what you can do instead is pretend to overlap these triangles. Pretending to overlap the triangles like this, you can still use the same side lengths, 1 and root 3, but now in the formula you can just remove the divided by 2, because now you're just multiplying base times height to find the area of 2 triangles, and this makes it easier to solve for the area of multiple triangles, in this case 4. So using this, I don't have to divide anything by 2. I want to keep these the same, but it'll calculate the area of both of these triangles. So it's 5 times 5 root 3, or 25 root 3. So both of these triangles combined, their area is 25 root 3. And then I add that here as well, because all of these are congruent. I know that all 4 of these triangles combined are 50 root 3. So it's 100 root 3, which is the area of this rectangle, plus 25 root 3, plus 25 root 3. This means that the area of the triangle is 100 plus 50 root 3, or 100 root 3, 100 root 3 units squared, or 150 root 3 units squared. That's the answer. Alright, next problem I'm going to be going over number 16. In a triangle, a base and its altitude are on the ratio of 3 to 2. The triangle's area is 48. Find the base and the altitude. So I've already constructed the problem here. We know the area is 48 units squared, the base is 3x, and the altitude is 2x. And we want to find the base and the altitude actually are. So we know that in order to find the area of a triangle, it's base times height over 2. If we know this, we can just plug that into the equation here. We already know the base, and we already know the height, or the altitude. So we know it's 3x times 2x over 2 is equal to the area. And we already know what the area is, which is 48, so we can plug that in. So we know base times height over 2, which is the area of a triangle, equals the area. And we already know the area, and I set the triangle to 3x is to 2x as well, because they're in a ratio of 3 to 2. This way, x functions as a scale factor for the triangle. So now all we need to do is solve for this equation. 3x times 2x is equal to 96. I'm going to multiply each side by 2 to get rid of this divided by 2. And then this is 3 times 2 times x equals 96. And this is 6x squared equals 96. And x squared is equal to 16. 10 plus 6, which is 16. And then x is equal to 4. So now we know the scale factor of the base and the altitude. Now all we need to do is plug it in here. So we know that the base is 3x, which means it's 3 times 4, or it's 12 units. And we know 2x is the altitude, or 2 times 4, which is 8. And that's the answer. Alright, next problem is number 25. We have to find the measurement of angle A in this parallelogram and what the measure of AX is. So, and something I noticed about both this side here 6 and this side here 4 is that both sides are altitudes. They create 90-degree angles. I know if we want to find the area of a parallelogram, it's the base times the height, or the base times the altitude. And if you flip the shape, I know that this is the altitude and this is the height and this is the base. So I know that the area of the shape is 6 times 8, or 48. I know that the area is 48. However, we're not trying to find the area, we're trying to find length AX. So in length AX, I know it's also the base times the height. And if 48 units squared is the area, we just need to plug in base times height is equal to 48. And since we already know the height, it's base times 4 is equal to 48. Base times height is equal to the area. We already know the area is 48 and and the height is 4. Now we just need to solve again. This is base is equal to 48 over 4. Base is equal to 12. This is the answer to B. To A, not gonna lie, I kind of forgot that one existed. But since we know that this angle is 30 because it's a 30, 60, 90 triangle, because the hypotenuse is double of one of the sides, and this is a parallelogram, I know that the opposite angles are congruent, which means that angle A is also 30. So the answer to A is 30. Answer to B is 12 units. And that is the answer. Next problem is number 26. This problem is saying if the diagonals of a rhombus are 10 and 24, we have to find the perimeter of the rhombus. So I've constructed a little rhombus here, and all the sides are congruent, because that's the property of the rhombus. And if all the sides are congruent, that'll be more important later. But, one of the diagonals is 10 and the other is 24. I also know something about the diagonals in a rhombus, is that they create 4 equivalent or equal triangles, 4 congruent triangles. So I know that it also splits them equally. It splits the diagonals equally. So let's say this diagonal right here is 24. That means this side has to be 12, and this side also has to be 12. And if the other one is 5, this one is 5, this one is 5. And something you notice here is that this actually creates a part of a right triangle family, or the 5, 12, 13 triangle. So I know that this side has to be 13. Because of rhombus, all the sides are congruent. So the problem is as simple as 13 times 4, which is 40 plus 12, or 52. That's the answer. Or it's not units squared, it's the perimeter. 52 units. That's the answer. Alright, number 27. We have to find the area of an equilateral, or the area of an equilateral triangle is 9 root 3. We have to find the length of one of the sides. And then question B, find the formula for the area of an equilateral triangle with sides S units long. Alright, let's do A first. So, we know that the area is 9 root 3. This is similar to a problem we did earlier. If I know the area is 9 root 3, I know that if I just take this side of the triangle, flip it over, the area of the entire triangle would be x root 3 times x. So I know that would be the area, and because I already know the area, which is 9 root 3, it's as simple as plugging in an equation. So I know x times x root 3 will equal to the area, which is 9 root 3. So now I know this, and I can simplify this. X times x root 3. This is x squared root 3 is equal to 9 root 3. And I can just take out both of these 9 root 3's because they're on both sides of the equation. So I divide both sides by root 3. And because this is 1, it's x squared is equal to 9. And this is equal to x is equal to 3. Okay, so we've just solved for x. So each side is 2x. X plus x is 2x. Each one of the sides of the equilateral triangle is 2x, which means that if we know x is 3, then we know 2x would have to be 6. So we know each side is 6 units. All right, that's A. B, I have to find the formula for an area of an equilateral triangle with s units long. So we know each side is s units. Actually, wait, I'm gonna make this a little bit bigger. Okay, so I know each side is s units long. This means that each side is s divided by 2, or s over 2. Okay, and and I know this, that this is x root 3, 2x, which means this will have to be x, or s over 2 times root 3. And s over 2 times root 3 is the same thing as saying x over 2 times root 3 over 1, or s root 3 over 2. So I know that this altitude will always be s root 3 over 2. And now it's as simple as just doing the previous problem. All I have to do is multiply this by this, s over 2 times s root 3 over 2. And in multiplication, we always multiply the denominator as well. This means that this s times s times s, or s times root 3 as our numerator over 2 times 2, or 4, as our denominator. This can be simplified again into s squared times root 3 over 4. This is our answer. The area given the side length s will always be s squared times root 3 over 4. That's the answer. All right. Number 28. Given this shape, what is the area of this triangle? So, first thing I'd like to do in any sort of problem ever, any sort of math problem, is find as much information as I can. So, I know that the interior angles of a triangle sum up to 180. So, this angle of the triangle will have to be 180 minus this sum of 120 and 45. And I know 120 plus 45 is 165. So this angle would be 180 minus 165, or 15. So I know this angle right here is 15. And this is where this problem gets interesting and why I'm going over it. It's truly an interesting problem to me. So what I can do here is try to find ways I can create a right triangle anywhere. Right triangle is always way more easier to work with than any other type of triangle, because we can use the Pythagorean theorem, which is so much more useful instead of using something like Heron's formula if you don't have the height or the altitude. So try to find a right triangle here. Okay, so the easiest way to approach this problem is you can either create one down here, like this, or create one on the top. Here, okay, it's gonna look something like this. Right angle. Okay. Oh, it's really bad. Okay, so we have a right triangle here. What we know about this right triangle... Oh, wait, I forgot to label this side. What we know about this right triangle is x root 2. It's a 45, 45, 90. Because this side right here is 45. This side right here is 90 degrees, which means this side has to be 45. This entire angle has to be 45. And because right now this angle is 15, this one right here would have to be 30. And what do you know about this triangle right here? This one right here ending at 8. About this triangle right here is that if one side is 30 and the other side is 90, the last side will have to be 60. So we know this angle right here is 60. And once again, opposite side of 30 will always be half the hypotenuse, so we know this side is 4, which means that this side will have to be 4 root 3. This already gives us a lot more information that we can work with. Because both these sides are congruent, 45 and 45, this means that this side and this side are congruent. Or you could say this is 4 root 3 minus 4, but we don't necessarily need this information. What we do know is that because the sides are congruent, this entire side right here, this entire side is 4 root 3. Alright, so we know that now there are two triangles that we can work with. We have our bigger triangle, which is this, which looks like this right here, which is 45, 45, 90. And we have our triangle here, which we have all sides for, which is a 30, 60, 90. Okay, and we know this triangle is inside this triangle. And the only remaining triangle we have left is the triangle we're trying to find the area of. So this means if we find the area of this triangle, subtract the area of this triangle, we'll find the area of this entire triangle right here. So let's do that. Let's start with this triangle right here, 4 root 3 and 4 root 3. Once again, multiply 4 root 3 times 4 root 3 over 2. So I divide one of the sides by 2. It's 4 root 3 times 2 root 3, which is 8 times 3, or 24. So I know the area of this entire triangle will be 24 units squared. What else do we know? What else can we solve? We already know all the side lengths of this side of this triangle. So once again, I find base times height, which is this side. Divide one of the sides by 2. 4 is probably the easier number to work with. Let's divide it by 2. So it's 4 root 3 times 2. This equals 4 times 2 times root 3, or 8 root 3. And since we know both of these triangles now, we just need to subtract them. So 24 minus 8 root 3 will give us the area of this triangle. But because this can no longer be simplified without rounding, this is our answer. 24 minus 8 root 3 units squared. Never forget the unit squared.
Hi, Randy. Say hi.
Okay, anyway, next problem, number 29. Find the area of the parallelogram, and it looks like this. Not a very good artist. Okay, so we know this side is 5, and this side right here is 20, and we're given this angle right here is 30. Once again, in a parallelogram, opposite angles would be congruent, so we know this is 30. What else do we know about quadrilaterals in general? All the interior angles will add up to 360. Now, if we know this angle is 30, this angle is 30, these two angles have to be congruent. It has to be 360 minus 30, or minus 60, which is 300 divided by 2. Divide this entire thing by 2. 300 divided by 2 is 150. So we know that this angle right here, so we know this angle right here and this angle right here are 150. Like this. And to double check, 150 plus 150 is 300, 30 plus 30 is 60, 300 plus 60 is 360. Okay. Now, if we know that this angle right here is 150, we can create an external right triangle that'll help us solve the problem. So let's create this right triangle here, and we already have a side, which is the hypotenuse. And because this is a straight line, and straight lines equal 180, then we know that this side will have to be 180 minus 150, or 30. And this is a magical angle number. Now we know this is a 30, 60, 90. So this will have to be 60. And because it's a parallelogram, we're trying to find base times the height, which is this side. And it's pretty easy for us. Side opposite to 30 degrees is always half of the hypotenuse in a 30, 60, 90 triangle, which means if this is 20, this has to be 10. Base times height, 5 times 10 is 50. 50 units squared. That is the answer. All right, so problem number 30, well, not 29, problem number 32. We know the perimeter of the parallelogram is 154, and we need to find the area of the parallelogram. Now, because this is in a rhombus, we can't assume all 4 sides are congruent. We can, however, label them. So we know this side is x, and this side is x. We know opposite sides are congruent. We're just trying to solve as much as we can using only one variable. So if this side is x, and this side is x, and we know the perimeter is 154, we know both of these sides together will have to be equal to 154 minus 2x. Right? And because there are 2 sides, we can just divide this by 2. So this is 77 minus x. So we know both sides here are 77 minus x. I wrote this way too close to that. So we know all of these sides now. Now, it's just as simple as plugging in and solving. This is similar to the other problem we did. We know both of these are the heights of this parallelogram, depending on the orientation of it. So let's try to do it with this side first. We know that the base is 77 minus x, and we know the height is 10. So we know the area will have to equal 10 times 77 minus x, like this. And we also know that if this side is x and the height here is 12, then we know that the area will also have to equal 12x, or base times height. And because both of these equal to the same thing, we can just plug them in and equal to each other. So 12x is equal to 10 times 77 minus x. And once again, it's simple as just solving the equation. 12x is equal to 770 minus 10x. I'm distributing the 10. And I know I can add 10x to both sides to move this over here. So 22x is equal to 770. X is equal to 770 over 22. So if x is equal to 770 over 22, x is equal to 385 over 11. X, 385 over 11 is 350. 35 times 10 plus 35 times 1, and that works. So x is equal to 35. Now we know x. All we need to do is plug it into one of these equations. 12x is a super easy equation I can plug this into. So our answer will be 12 times 35. It's 35 times 10 plus 35 times 2, which is 350 plus 70, or 420. That's our answer. 420 units squared. Thank you for tuning in. Thank you for tuning in. Thank you for tuning in. And I'll see you on the next episode.
And I keep like a nerd. Head up the guys like bros the word. I'm fly like a bird.
I actually-
And they really want beef, niggas spend to third. You know they ain't spinning, I strip. He talk tough, he get hit in his lip. Put that boy in a digital clip. Now they watching the screen like I'm sending a pic. But we ain't talking basketball. I did it to myself, so I can't be mad at y'all. Stack up, then add it all. And I